So the profit of this company is modeled. Whoa, gotta turn the sound down. It can be modeled by x squared minus 12x plus 32. And the year 2000 is labeled as year 0. So the first question asks, how much did the company earn in 2000? That will just be the constant. So the answer is 32 million. You all right, Peyton? Okay, good. Yes. No, not your voice, only mine. Do you want to talk into the microphone? I wonder if that'll show up or not. I don't know. All right, number 2. So we have a graph. We know that the parabola crosses at 32 on the y-axis. And we want to know, when was the company making money? Meaning, when was the value of the company above the x-axis? Well, you're not allowed to graph on this worksheet. So we could graph it and figure it out. How else could we figure it out? We could put 0 in for y. So here's the function, x squared minus 12x plus 32. And I want to know, when does this equal 0? Which just means find the roots. We need to figure out where this graph crosses the x-axis. So we have it set equal to 0 already. Let's factor x minus and x minus. Are there factors of 32 that add to be negative 12? So 8 and 4. So my roots are x equals 8 and 4, which means that my parabola looks like this, where this is a 4 and this is an 8. So what is the interval where the company was gaining money? 8 to infinity is one of them. So this piece over here is a positive piece. So x equals from 8 to infinity. Do we include 8? Why not? It's on the axis, and on the axis is 0, and 0 is not positive. So no. Do we include infinity? No. Are there any other years when the graph is above the x-axis? From negative infinity to 4. Anybody disagree? You should. The company did not exist until year 0. So this part of the graph doesn't actually exist. So the interval would be from 0 to 4. Is 0 included? Yes. So 0 gets a bracket. Is 4 included? No, it's on the axis, so that doesn't count. All right. Number 3, when was the company losing money? From year 4 up to year 8. Do we include either of those? Nope. So that's the interval of negative values. And when did the company make no money? At 4 and at 8. So x equals year 4 and year 8. Okay. Everybody okay with that so far? So number 5. What was the worst year that the company ever had? How do you know it's 6? So can we assume that if I draw a line down the middle, that the left side is a mirror image of the right side? Yes. Parabolas are symmetric. They are all symmetric, which means halfway between 4 and 8 is the worst year, which is 6. Well, how can I calculate the 6? What if it was 1.8 and 7.3? How do I find the midpoint there? What's that? It's the average, right. Add them up, divide by 2. So 4 plus 8 is 12. 12 divided by 2 is 6. So year 6. Yes. The worst year was year 6, x equals 6. Problem number 6. How much did the company lose in its worst year? What are we looking for? The minimum. I'm looking for the y value. So right here is 6 comma some negative number. And if you had your calculator, you could use the minimum button. What if you don't have a calculator? Plug the 6 in for x. So I look at my function. I'm going to put a 6 in here and in here. So I get 6 squared is 36 minus 12 times 6 is 72 plus 32. So 36 and 32 is 68. 68 minus 72 is negative 4. So the worst year was a loss of $4 million. They must be selling Mr. White bobbleheads again. Negative 4 million, yeah, is the answer. Okay, number 7. How much will the company make this year, at the end of this year? Plug in 13, because the first, or year 0 was 2000, so now we're in 2013, so plug in 13. So 13 squared minus 12 times 13 plus 32. Oh, look at this. I don't even need a calculator. If I have 13 13s and I subtract 12 13s, what do I get? 13. 13 plus 32 is 45 million. I like this company. If you can last 13 years, you'll be a rich person. You can make it through those tough years. Okay, problem number 8. How much did the company make in its second year? How are we going to figure that out? Plug in 2. So 2 squared minus 12 times 2 plus 32. 4 minus 24 plus 32. Is it 12 million? All right. Now for the fun one. Let me go back to the graph. Go back a little bit more. That's good enough. Okay. That was a waste of my time. Sorry, guys. So, number 9 says, when will the company be worth 21 million? I know a couple things about the graph. First off, this is a 32. This is a 4. And this is an 8. So, when it says, when will the company be worth 21 million, what am I looking for? Where what is going to hit 21? Yeah, you're right. You mean on the x-axis? Right. Okay, good. So up here at 21 million, if I were to draw a line across there, I know the y value is 21 million. I want to know which x values give me 21 million, and there are 2 answers. How are we going to figure that out? Plug what in? You could guess. The trouble is, if you didn't know there were 2 answers and you were guessing and you found one answer, you'd probably say, oh, I got it. And what if you had a different equation that had 3 answers or 4 answers or 5? That'd be kind of a mess. You could use the table value on your calculator, but then again, you'll run into the same problem. How do you know there are more answers? There's got to be a way, using algebra, to figure out all of the answers and to make sure that you have them all. Well, this is a y value, so let's plug in the y value. Let's look at x squared minus 12x plus 32, and I want to know when this equation equals 21. Well, now let's just use algebra. what do we do to solve for x? Okay, now don't write any of this down. If I subtracted 32 and put it over there, what am I going to do with what's left? What's that? Can you add x squared and 12x? No. So you can't separate these, and you can't combine them, so that actually doesn't work. All right? Well, when this equaled 0, how did we solve it? We factored it, because I wanted to know when this graph hits the x-axis. But when I write up here, 21, it no longer hits the x-axis. So we're going to do a trick. We're going to take this graph, and I'm going to pull it down until it hits the x-axis. So I'll take my original equation, I'll knock off a bunch of the numbers, and when it hits the x-axis, I can factor it and find the answer. How far do I need to pull it down? 21, right? So I'm going to subtract 21 from both sides, and I get x squared minus 12x plus 11. And what does it equal? 0. So really, all you have to do is move everything to one side and get a 0 on the other end, and then you can factor it. So those two equations are exactly the same shape. But the second equation, we've knocked off $21 million, which yanked the graph down. And now where that graph crosses the x-axis is the exact same place that this graph crosses 21. And that's a trick you're going to be doing a lot on this worksheet. You don't need to, because we already know that the answer is something comma 21. We just want to know what the x's are. And the x's will be the same in both equations. Yeah. So you don't even need to add 21 back when you're done. All right, so looking here, x minus and x minus. Are there factors of 11 that add to be negative 12? 11 and 1. So my roots are x equals 11 years and 1 year. Okay, did that make sense to everybody? Kind of? Well, let's try it again. On the next problem, number 10, change the 45 million to, say, 77 million. Because we already know the answer for 45. It was in a previous question. I'm just not very bright. So I want to know, when does x squared minus 12x plus 32 equal 77 million? How am I going to solve this? Move the 77 over so it equals 0. Minus 77 minus 77. X squared minus 12x 45 minus 45. Oops, I said 45. 45. Now that it equals 0, I can factor it. So I factor x minus something and x plus something. 3 goes in, 1 goes into 45 times. 2 doesn't work. 3 goes in 15 times. Does that work? Yeah, 3 and 15. So it's minus 15 and it's plus 3. So when is it worth 77 million? In year 15 and in year negative 3. Does anybody other than Cassidy have a problem with that? Do you have a problem with that? Why? There was no company 3 years ago. So the graph hits the x-axis at negative 3. But can that even be an answer? No, because there was no company. We were told that the company began at year 0. So the answer is year 15. All right, turn the page. Connor, this one was written just for you. Suppose that a friend of yours is holding a meat cleaver and standing atop a ladder at an unknown distance from you. Your friend has placed an apple on the top rung of the ladder and suddenly chops the apple in half. Each piece of the apple shoots out sideways and falls to the ground as shown in the diagram. The trajectory of the apples is modeled by that function. X is the distance in feet from where you are standing to the apples, and y is the distance above the ground in feet. Okay? So, number one. What? Yeah? Uh-huh. Ouch. All right. So, number 11. How far from you did the apple pieces hit the ground? How are we going to figure that out? Find the roots. So my equation is negative x squared plus 20x minus 84. I'm a little bit confused. What's wrong with that quadratic? It opens down. We have not dealt with the quadratic that opens down yet. In fact, those rules I gave you for factoring, they only apply if the quadratic opens up. So what do? We times by -1 or divide by -1 or flip it upside down, however you want to say it. So if I times this whole thing by -1, then I get x squared minus 20x plus 84. Will that change the graph? Yes. The new graph looks like this. But it will not affect the roots. You can multiply by any number you want, and it will change the graph, but it will not change the roots. Okay? So now we factor x minus and x minus. Factors of 84 that add to be 20. 1 doesn't work. 2 and 42, that doesn't work. 3 and 30, what is that? 3 and something doesn't work. 4 and 21, that doesn't work. 6 and 14, that's it. So 6 and 14. So how many feet from where you're standing? 6 feet and 14 feet. So this number here is a 6, and this number here is a 14. How far from where you're standing is the bottom of the ladder? How'd you get 10? The average of 6 and 14. 6 plus 14 is 20, divided by 2 would be 10 feet. And we assume that the middle of the ladder, just to make things easier. Okay? Number 13. How tall is the ladder? How would we figure that out? What are we really looking for in that parabola? We're looking for the maximum. And we know where the maximum occurs on the x-axis. So if we plug in 10, we should get a y value that provides us with the maximum. So which function do I plug the 10 into? Does it matter? Which one should I plug the x into? The first one. If I plugged it into the second one, that's going to tell me this negative value down here, which will be the right number, but it'll just be in the wrong place. What if I divided the function by 2? Could I plug the 10 into the new function? No, it would be half as tall as it was supposed to be. So you always plug x values back into the original function. So we get negative 10 times 10 is 100 plus 200 minus 84. It's not negative 10 squared. It's minus 10 squared. And that's a good point. There's a difference between negative 10 squared and negative 10 squared. This one says square the 10 and make it negative. This one says square the negative. And in this case, we're squaring the x, not the negative. So that's a good point. In my head, that equals 16. Okay, so the ladder is 16 feet tall. So number 14 is a little tricky. How far from you, meaning where you're standing, is the top of the ladder? If I were to draw a line between the top of the ladder and where you're standing, what is that distance? Good. This is a right triangle. What's the distance for A? 10. What's the distance for B? 16. So I have 10 squared plus 16 squared, which is 356, equals C squared. And I like to do this because it's a little bit faster. 10 squared plus 16 squared. I don't want to push second square root, second answer, because I'm really lazy. I can just do raised. What is the square root as a fractional exponent? 1/2, so 0.5. And that'll save you some time. So the distance is 18.8 feet. That's how far it is from where you're standing to the top of the ladder. Okay? Number 15 is harder than that. How far from where you're standing are the apples 7 feet off the ground? So I want to know how far is it from here to here and from here to here. Well, do I know the height? Do I know those distances? What are they? They're both 7. Do I know the length along the ground? No. How would I find those? Drop the graph 7 units. So negative x squared plus 20x minus 84 equals 7. So now I subtract 7. Negative x squared plus 20x minus 91 equals 0. Everybody understand that? Okay. Well, I have a problem here. I need to times it by a -1 because it's a downward opening parabola, and I don't know how to factor those. So I'm going to change this to positive, change this to negative, and change that to positive. So I dropped the graph 7 units, then I reflected it, and now it opens up. And we have x minus and x minus. What goes into 91? Does 2? No. Does 3? No. If 2 and 3 don't, then 4 doesn't, and 6 doesn't. Does 5? No. What about 7? How many times? 13 times. So it's 7 plus 13 is 21. So this answer is 7, and this answer is 13. So go ahead and calculate those two distances using the Pythagorean theorem. So we have 7 squared plus 7 squared. Raise that to the 0.5. So one of them, the first one, is 9.89. Then 7 squared plus 13 squared. Raise that to the 0.5. And 14.7. All right, do you kind of get the hang of that? Makes sense to you? All right, number 16. How far from you is the middle of the ladder? So this distance is 18.8. If I take my 16-foot ladder and I cut it in half, what do you suppose the distance is going to be? Is it going to be half of 18.8? Why not? If I cut the ladder in half, shouldn't the distance cut in half too? You guys are smart. Good. If I were to cut the 16 and the 10 in half, then the distance would cut in half. So this is going to be some distance between 9.4 and 18.8, somewhere in the middle. Okay? So we're going to find 10 squared plus 8 squared is 164, and I square root that, and you guys are right. It is not half. In order to make the sides of a triangle cut in half, you have to divide all the sides in half. Okay. You and a friend spend the day cliff diving. I love cliff diving. The particular cliff you have chosen has some rocks at the bottom. To clear the rocks, you need to take a running jump off the cliff. If your height in feet as a function of seconds is given by that equation, answer each question below without graphing the function. Now, let me point something out. If you're standing on a cliff and you jump up really high and you fall all the way to the water, somebody else runs and jumps the same height and falls to the water. If all three of you jump at the same time, who's going to hit the water first? No. You all hit the water at the same time, because gravity is not affected by how fast you're going horizontally. If you shoot a gun and drop a marble at the exact same time and it's level ground and your gun is level, the bullet and the marble hit the ground at the same time. Your rate of falling down never changes. Well, I mean, it's constant acceleration. As long as the height is the same, then the point that you hit the ground. Right, right. if I jump this high and you jump that high, I'll hit the ground first. Yeah. But as long as these heights are the same, then everybody hits the water at the same time. Now, having said that, there is a picture there of a guy clearing the rock. The function is not a function of how far he travels. It's just a function of how high he is above the water for every given second. So if you plug in 1 second, that tells you how high he is. It doesn't tell you which one of these graphs he's following. In order to know that, we need to know how fast he's moving horizontally. Okay? So, number one, how tall is the cliff? 60 feet. That's easy. When are you going to hit the water? How will we figure that out? Find the roots. Now, there's something wrong with this equation. It's negative, and can we pull anything out? We could divide it by 2, or 8 doesn't work, but 4 does. So we could divide this by -4. And that will create a simpler equation that you can factor and find the roots. Well, I only see one root. How many roots are there? 2. Where's the other one? It's in the negative version, and that's not going to count. So if you get a negative number, you just throw it out. Okay, number 19. When did you reach your highest point? How would you figure that out? Well, I didn't tell you the answers. I'm just giving you some hint for your homework tonight. How am I going to figure out this point here? Take the 2 roots and add them together and divide them by 2. Okay? And then number 20, how high did you jump? That's a really tricky question. How am I going to figure out how high I jumped? Good. Good job, Camry. So let's say this is 3 seconds. Let's say that that is 3 seconds. How am I going to figure out the maximum at 3 seconds? Plug it into the equation. Into this equation or into the altered equation? It's got to be the original. Okay? Once I plug that number in, and let's say it's, I don't know, 75, how do I find the answer? If the maximum is 75, what's the answer to the question? We need to subtract off the height of the cliff to figure out how high you jumped. Good. And then number 21, how long does it take you to rise to your maximum height and fall back to the same level? What is that asking? So how long does it take me to get from here until right there? Dividing by -4. Yeah. So how am I going to figure out that? Drop it how much? So, well, this line is 60, so I'm going to set that equation equal to 60 and then subtract 60 and solve for x. And I know one of the answers is 0, right? Because this is going to have two roots, one here and one here, and one of them is 0, so finding the other one should be really easy. And number 22, if your horizontal speed is 22 feet per second, how far did you go to clear the rocks? Well, you know the equation, rate times time equals distance. If I know this is 22 feet per second, what is that going to be? We don't know the number, but where will I find this answer? It's this answer here. It's how long it took you to hit the water. Okay, turn the page. So that page is homework. Yeah. It's not 20. Not far out. It is an insane amount of height, but well, but 15 was wrong. That wasn't the right answer. Yeah, that 75 is not right. You need to figure out the correct value. It's not 15 and it's not 20. But it is really, really high. Okay. So Lulu has a photograph hanging on her wall that is 8 by 12. She wants to replace it by an enlarged photograph. This new photograph is going to be enlarged by the same amount that's not a percentage. So this would be like 3 centimeters and 3 centimeters instead of something like 50% and 50%. You're just going to add some number to it. So, and we know that the new photograph has twice the area of the old photograph. So we need to create an equation that will answer these questions. This one's kind of tough. The nice thing is, these are the same distance. And those are our unknowns. So let's call them x. So what are the dimensions of the new photograph? 8 plus x, but we'll actually flip that around. So one of them is x plus 8. That's this height. And this one is x plus 12. What else do I know? What do we know about the areas? It's double. So the area of the old photograph was, so this one is 96. So the big one must be 192. So the area equals 192. Well, how do we calculate this area? What's the formula for area? Length times width. Well, one of the lengths is x plus 12, and the other length is x plus 6. So x plus 12 times x plus 6 equals, we know how big it is, right? 192. Yes. Awesome. Hey, maybe it's a family member. I don't know. Yeah, that would be me. But it never said she was a student. Creepy math. Okay, so we can use these numbers to create a quadratic. And whatever that quadratic is, it equals 192. So how am I going to find x? Yeah, this will be x squared, something, something, something. So I subtract the 192 over so it equals 0, and then I factor it. And I'm going to get two x values. Okay? And then you'll look at the x values and figure out which one is correct. And then answer the rest of those questions. So that's your homework tonight. We will go over the answers tomorrow in class. Oh, tomorrow's Monday.